So welcome to the 19th lecture of this course. The last lecture I ended up with the minterms and maxterms with you. What do you mean by minterm? I told you minterm is the product of all variables and maxterm is the sum of all variables or all literals. Variable or literals, one are the same thing. All variables this is sum of all literals. In this case, a variable is represented by a by 1 and the complement of the variable is represented by 0 and vice versa in the case of maxterms. So if I define this minterms and minterms are product of all variables. It should have all variables first of all, and in minterms a variable is represented by x is represented by 1 and complement of x bar is represented by 0. In case of maxterm is sum of all variables where a variable is represented by 0. See, a, b, c represent by 0, or 0 represents the variable and 1 represents the complement of the variable. This portion I ended up with this in the last lecture. So today the topic which I'll cover is canonical SOAP form and canonical POS form. Now before I come to this canonical SOAP form and canonical POS form, what do you mean by SOAP form, which I have already discussed with you? A SOAP form, just see, a SOAP form, sum of product. Suppose I say that I have a Boolean expression a, b, c, a Boolean expression which is a function of a, b, c, and suppose I say it is equal to a bar b plus a, b, c plus a, c bar, AC complement. Now if you see that this is a SOAP form, in this SOAP form this is a minterm because it contains all the variables a, b as well as c. It is a function of a, b, c. So it is a minterm, but this is not a minterm and this is not a minterm. So it is simply called a SOAP form or a standard SOAP form. Many times it is also called a standard SOAP form. On the other hand, let's take another example. Suppose I have another Boolean expression which is again a function of ABC, and I say it is equal to a bar BC plus ABC plus say a bar B bar C bar, and there can be any other term also. Now if you see that this is a minterm, this is a minterm, this is another minterm, this is also minterm. Minterm is represented by small m, I told you, and maxterm is represented by capital M. So this is a minterm, this is a minterm, and this is a minterm. Such form is called, this form is called canonical SOAP form. This is called, of course it is a SOAP form, it is sum of certain product. So this is called canonical SOAP form. Canonical SOAP form is a SOAP form where every product is a minterm. Here standard SOAP form, every product was not a minterm here. Only this was minterm, this was not minterm. So I can say that canonical SOAP form is a SOAP form where every product is a minterm. So if I define it, what is a canonical SOAP form? A SOAP form, a sum of product where every product, each product you can say, where each product is a minterm. I hope that this is clear to you. Now at the same time, if you see, this is a minterm, this is a minterm, and this is a minterm. In other words, there is a sum of these minterms only. It is an addition of these minterms. So this canonical SOAP form is also known as the sum of minterms. It is also called, or I can say it is also called sum of minterms. One and the same thing. Either you say canonical SOAP form or sum of minterms. Now next article I'll cover, or next problem that I'll cover, I can say it is canonical SOAP form. Now how to convert a SOAP form into a canonical SOAP form, that I'll discuss now. That is next, let's treat as an example or an article how to convert a SOAP form or a standard SOAP form into a canonical SOAP form, into a canonical SOAP form. This is my target. How will I convert a SOAP form into a canonical SOAP form? I'll explain this with the help of problem or with the help of example here. Suppose I say that convert, simply convert a function is given to you. For example, suppose I say a Boolean expression is here. F is a function of ABC, and I say that suppose it is equal to a dot b plus ABC plus a bar c into canonical SOAP form. Suppose this is the problem. I say convert this. Now this is not in canonical SOAP form. This function is not in canonical SOAP form, and I have to convert this into canonical SOAP form. That is, I am converting the standard SOAP form into a canonical SOAP form. Now if you see here that this particular expression here, this one only, this middle one, is a min term. This is not a min term, this is not a min term, because C is missing here and B is missing here. It does not contain all the variables, or this does not contain all the variables. So I have to convert. Look at the solution of this. I'll go for this. F is given to me, F which is a function of A, B and C. It is given to me as a dot b plus ABC plus a dot c bar. Sorry, a dot c. It's not a dot c bar. It is a bar dot c. Now what I do, first of all, very first thing, look at this. If you see, what I simply do, I multiply this by 1. This is already a min term, no need to touch it, and I multiply this also by 1. Why? I know that any function a dot 1 is equal to a, so it will not affect my result. The result will remain same. Now see what I do after this. This F A B C is equal to, this F A B C is equal to a dot b. What is missing here? C is missing. So I write this one as C plus C bar. Reason being that a plus a bar is equal to 1. So this one I write as C plus C bar. There is already a min term, no need to touch it. ABC plus a bar C, a bar dot C. What is missing? B is missing. So I write this one as B plus B bar. I hope this is clear to you. Now I expand these brackets here. So I can say that F, which is a function of ABC, is equal to a dot B dot C plus a dot B dot C bar plus this ABC as it is, A, B, C, it is dot by default, plus, now I can write this A bar CB, can also be written down as A bar BC. Remember that it should be in the same order first of all. So it is A bar BC, A bar BC plus A bar B bar C. I have applied the commutative law here. A into B is equal to B into A. So I hope that this is clear to you. Now if see, just check if there is any repetition. If you see that this function is repeated here, just check for any repetition. I will not repeat it again. This function is repeating here. ABC and ABC. I'll write it only once. Why? Because A plus A is equal to A. So ABC plus ABC will be equal to ABC. So I write this function. Look at this. I write this as ABC plus ABC bar plus A bar BC. This term I have written only once. A bar BC plus A bar B bar C. I hope that this is clear to you. Now look at this. These all are min terms now. Although this is also, I have converted this into canonical SOAP form here only. This is F, which is a function of ABC. But let me write down in a different way also. Although this problem completes here itself. Now what is here? There is a min term. In a min term, I represent a variable by a 1 and the complement of a variable by 0. So what I simply do here, just try to understand this point here. This ABC, I write this as 1, 1, 1. This is 1, 1, complement is 0. This is 0, 1, 1. This is 0, 0, 1. I am representing all variables by 1, and the complement, wherever I have complement, I am representing this by 0. Now 1 1 1, if you see this 1 1 1 is 7, so this represents M7, minterm with decimal equivalent 7. I told you in the last lecture also, this is 1 1 1, ABC is M7. Similarly, this ABC bar is M6. ABC bar, if you see 4 2 1, this is M3, and this is M1. If you see from here, it is M1. I hope that this is clear to you. Just check out if there is any mistake here. ABC bar, ABC, A bar, B, C, A bar, B bar, C. I write this as 001. So this is this much here. I hope that this is clear to you. Now, what I do, I write this in the simply ascending order, or now I can say this is this plus this plus this plus this. And many times this expression only is written down as f as a function of ABC is equal to sum of, this is sum of certain minterms, sum of small m, and I simply write the decimal equivalent of this and writing in the ascending order 1, 3, 6 and 7. 1, 3, 6, 7. I hope that this is clear to you. This is how it is, sum of minterms. So this is representing sum of minterms. So next topic, I hope that this canonical SOAP form is clear to you, and how to convert a SOAP form into standard SOAP form into a canonical SOAP form. I hope that this is clear to you. Next, let's come to canonical POS form. Next point is canonical POS form. Canonical POS form. What do you mean by this canonical POS form? I have discussed with you canonical SOAP. So now I'll cover the canonical POS form. And what do you mean by this canonical POS? Let's discuss the POS form first. Just as I did in canonical SOAP form, a POS form, product of sum. Look at this. What do you mean by this canonical POS and canonical SOAP? A POS form, suppose I say again f, a Boolean expression which is a function of suppose ABC, and suppose I say it is equal to, let's take this example only. Suppose I take this is equal to, I simply take a plus b plus c and a bar plus c. Say it is a plus b dot a plus b plus c dot a bar plus c. This is a SOAP form, because if you see that this is a mixed term, this is a mixed term, this is not a mixed term, this is not a mixed term. Now I have another example. Suppose I say f, which is a function of ABC, and I say it is equal to a bar plus b bar plus c bar dot a plus b plus c dot some other thing. Suppose I say it is equal to a plus b plus c bar. Now if you see that this is a mixed term, this is a mixed term, this is a mixed term. Of course it is a product of sum. This is a sum, this is a sum, this is a sum, but every sum is a mixed term, and such form is called canonical. Such term is called canonical POS form. I hope that this is clear to you. Now if I define this, what do you mean by canonical POS form? So canonical POS form is a POS form, is a product of sum in which every sum, each sum is a mixed term. Is a mixed term. If any one of sum is not a mixed term, it won't be a canonical SOAP form. It will be a POS form. It will be a standard POS form. At the same time, if you see, this is a product M, this is a product M. So M, some value suppose, another max term, another max term. So it is nothing, it is product of max terms. So this is also known as, this one I can say that this is also known as canonical pause, or I can say that this is also called product of max terms. It is product of max terms. I hope that this is clear to you. Either canonical pause or product of max terms. Now let's take an example as I did in the previous case. How to convert, let's take an article, how to convert a pause into a canonical pause, into a canonical pause form. How I like convert a pause form into a canonical pause form. Let's take an example again. Suppose I take an example. I have an example. Suppose I say that f is a function of ABC again, is a function of ABC, and which is equal to, suppose I say it is equal to a plus b, a plus b. I'll skip one step here. Dot a plus b plus c dot a bar plus c. I hope that this is clear to you. I have to convert this. Example, I have to convert this into canonical pause form. This is my target. I have to convert this into canonical pause form. I hope that this problem is clear. Now look at this. What I'll do here, I'm writing solution here. This is given to me. This is already, this function, this one is already a max term. This is not a max term. So what I do, I simply add a 0 here. I simply add a 0 here, and similarly I simply add a 0 here also. I simply add this plus here, please. I simply add a 0 here because a plus 0 is equal to a. I know that a plus 0 is equal to a. So it will not affect my result. Now I can say that this is equal to this function of ABC. I can say a plus b. Now this 0, what is missing? C is missing. So it is c dot c bar. Why? Because a dot a bar is 0. So I write this as c dot c bar dot. There is already a max term, no need to touch it. So it is a plus b plus c. Then this will be a bar plus c, and this 0. What is missing here? B is missing. So I write this as b dot b bar. This is the procedure that will flow. Now look at this. I can say, I can expand this, a plus b plus c dot a plus b plus c bar. I hope this is clear to you. This is already in this form, a plus b plus c. No need to touch it. This one, if you see, again I am writing, it is a bar plus c plus b dot a bar plus c plus b bar. I am writing in the form of a, b and c. So it is a bar plus b plus c dot a bar plus b bar plus c. I hope that this is clear to you. Again, I check if there is any repetition here. If you see that yes, there is a repetition here, this is repeated, and I write it only once. So I write this as a plus b plus c dot a plus b plus c bar. This one, this I have already written. Next expression, a bar plus b plus c, a bar plus b plus c dot a bar plus b bar plus c here. Now although this has been converted into canonical SOAP form, my job is done here at this stage only. But I'll write this in the expression in as a product of max term. This is a max term, this is a max term, this is a max term. Now in max term, a variable is represented by a 0. A variable is represented by a 0. So this is 0, this is 0, and complement of the variable represented by 1. This is 1, 0, 0. This is 1, 1, 0. I hope that this is clear to you. Now look at this. I write the max term. There is a max term, and the corresponding value of this max term, if you see this max term, it is 0. 0, 0, 0 is 0. This is 0, 0, 1 is 1. This is 4, and if you see, this is 6. So I can say that this is product of these max terms. This Boolean expression, which is a function of a, b, c, can be written down as product. That sum was represented by sigma, and here this product pi of capital M, product of these max terms having decimal equivalent 0146. 0146. So it is a product of max terms. This is a product of max terms here. So I hope that canonical SOAP and canonical POS is clear to you, and how to convert from a standard SOAP form or to a standard POS form into a canonical SOAP or canonical POS. I'll stop it here. Thanks for the time being.